Hello everyone, this is Makercast. I'm Renan Leperowski and those are our guests for today. We are
Hello.
going to be talking about our projects. So I will let everyone go in order and introduce themselves. Chris, maybe.
All right, I'll go first. Yes, I've been struggling with OBS and getting my streaming set up. I think I'm going to resign as any sort of person with any technical knowledge from now on because apparently I can't work anymore. So yeah, hopefully I've got something interesting to demo. Yeah, we'll see what happens. Pat, over to you.
Well, hello. I'm Pat Deegan. I have a YouTube channel, Psychogenic Technologies, and I show some of the stuff that I do. And today I'm going to do exactly that. I've been working on something for dev, which is what I usually end up doing, tool stuff. And so I've been having an interesting time working with it. So I'm going to show a little bit what that's about.
Thank you. And I'm going to also show some of my robot projects, so we can go and start things. So Chris, your problems are gone, right? So you can go first. Or do you want to go?
I can go first, yes. Pat, I think there's a bit of an echo from your side.
We'll try to handle it.
Cool, right. So, yeah, what have I been up to? So I've been making my ESP32 Spectrum and playing around with touch. So, deshipu, if you want to share my screen, I can walk through what I've been up to. So here's my original version of the touch Spectrum, and this works really well. But there's a couple of issues with it. So one of the problems is if I just flip to another screen, what I'm doing is I'm using a matrix of touchpads. So I'm only using, I think it uses 13 touchpads, and we have kind of columns and rows, which is really great because it just uses 13 pins, doesn't need any other ICs. And on the actual PCB, if you look at this, then you can see each pad, if I zoom in on one of them, so you've got one touchpad here, and then another touchpad here. So when you touch it, that basically triggers two touchpads, and I've got 40 keys. So if we switch back to the camera, I can show you this working. So if we just, let's just go into basic. So you can see the screen here. I hope that's actually visible. So I can do basic programming. So say I want to print hello world. Well, this is where we hit a bit of an issue because the Spectrum keyboard's quite interesting. You need to do lots of combinations of keys to get things. And one of those is symbol shift and P gives you a quote mark. Now, with this current keyboard, what I actually get, if I zoom in here, is a bunch of semicolons. So the problem is I'm not able to disambiguate key presses very well. So it's kind of seeing a different bunch of key presses from what I want. So let me just adjust my camera. So that's quite a problem. Now, what I did for this original version was I switched into a mode using sticky keys. So you could hit symbol shift and then hit P, and it would stay in symbol shift mode until you hit the next character. And that kind of worked okay, but it's not ideal. So I started thinking, how can I get my 13 touch pins into 40 independent touch pins? So what I did is I had a look at the trace you get when you're actually doing sort of a touch pin. And you get this kind of weird repeated pattern on the touchpad. And if you zoom in, if I can find my zoomed in one, let's find that. Yeah. So if you zoom in, what you can actually see is this sawtooth pattern. So all the ESP32 is doing, it's charging up the touchpad from one voltage to another, and it's timing how long it takes to charge and discharge. So it's really just an analog signal. So what I thought is, well, why not, if I can find the screen, why not use a touch multiplexer? So I found these 74HC4051. Now these are analog multiplexers. So what you can do is you can feed in one common analog line and you get 8 analog lines out. So with these ICs, potentially I could just use 5 of them and that would give me 40 pins because I've got 5 touch pins going out to 8 channels. So if I bring in another thing on my desk, I built a little prototype of this, which I'm sure you'll find quite interesting. So here's my multiplex touchpad prototype. And I think I like my touch keys here, a bit of tin foil. So if we power this up, what we've got here is I've got one of these analog multiplexers in here. There's one touch line, which is this green line coming into it, and it's being multiplexed out. And then I've just connected up 8 lines to some LEDs so we can see if pins are touched. Let me just shift that up a bit. So this was just a quick test to see if this actually works. Can I multiplex one touch pin out to 8 different touch pads? And hopefully it works. So you can see I can touch all these pads individually, and I can do multi-touch. So I can basically touch them all and it will pick it up. So that's all 8 of the pads touched, and you can do individually, and it's really quick. So all that's happening really is the ESP32 is scanning across the 8 channels, checking the touch pin on each time it scans to a different channel, and seeing if it works. And it appears to work really well. So that was my proof of concept of, is this actually going to work? So based on that, let me just pull out my current version of the code in 1 second.
So you trigger the touch check manually, like you change the address, you trigger it, you change the address.
Yeah, change the address. You have to wait for a small delay for the touch FSM to stabilize, and then you can sample the touchpad and see what the touch value is. So you switch the address, delay for a little bit, sample the touchpad, and then move on to the next address, delay for a bit, sample the touchpad. And you can tune things so that the delay is pretty small. So the FSM has a small kind of idle time while it kind of stabilizes and decides whether or not there's going to be a touch, and then it starts sampling again. So it works amazingly well. I didn't think it would work because it's the kind of thing that probably shouldn't really work, but it does.
There's no calibration for the touchpad? Or they're all similar enough that it doesn't matter?
So I do some calibration. So when I start up, I sample all the touchpads and sort of read the values, take an average, and then I use that for thresholding the next touchpads. So the multiplexer is bidirectional, yeah. So it works both ways. So they're amazing ICs. So what was really impressive is, if I find the right website, the price of these is unbelievably cheap. So they've been around, I guess they've been around since the 1970s. So the actual price for these chips on AliExpress, it's kind of less than 10 cents for an 8-channel analog multiplexer. And it's made by so many different manufacturers. There's everyone makes them. So I think they've turned into almost jelly bean components. So it's crazy. I can't believe they're so cheap. It's absolutely mad. So I switched over my design. So if I look at my new schematic, so this would have been smoother if OBS was working. But so now what I've got 5 of these multiplexer chips. So when I got this manufactured, that came to a total of $1 for all 5 of those chips when it was fully assembled. And then now each pad is actually its own completely independent touchpad. So there's no more multiplexing or matrices. It's just individual touchpads. And if you look at the PCB, it's just a solid touchpad now. Routing this was quite hard work on just 2 layers. So 40 traces routing out to these 5 chips was entertaining, and it was a long night of routing. But now if I bring in my latest version of the Spectrum, so let's move that out of the way and pull this in. So here's the new version, fresh off the PCB press. Let's try and get that plugged in. So now, if I plug in the SD card so it doesn't go into an endless boot loop, which is currently there's no not a lot of error checking in my firmware at the moment. Okay, so if we go into basic now, then I can actually get my quote marks. So there you go, proof that it works. So
Nice.
we can get quote marks now. So
Well, you have N key rollover. I mean, you can press all the keys now.
I could push every single key if I wanted to. Yeah.
You could make a steno for it.
So yeah, there we go. It works. And it is. I mean, it's kind of, you kind of think that's not really important, but actually, it is really important. So quite a few games weren't really working very well. So Elite was a really bad one. So if I bring up Elite, what was happening with Elite is if you commander's name, Chris. Right. Commander's name, come on, work. Okay. Exit. All right.
By the way, can you make it full screen again?
Yes. If I can find where the full screen thing's gone. Yeah, there we go. So yeah, this is Elite. So the problem with Elite is you have to push quite a few keys at the same time. And what I was finding is when you push the S key, which is kind of pitched down, and you rolled, the your speed would decrease to 0, which isn't really what you want to do when you're in the middle of trying to fight off pirates and stuff. But that's all fixed now. So yeah, so I can push every single key on the keyboard, and they all work. It's pretty cool. I like it. So yeah, so this new version of the ESP Spectrum, it's now got an on-off switch, which is a nice feature. So you can turn it off and on. I've now got the display actually on the PCB, so there's a nice connector. And I used a considerably cheaper SD card socket, because the one I was using seemed to cost about $1. This one costs like 10 cents again. So not only have I added more chips, I've actually decreased the BOM cost with a bit of optimization. So pretty good. Yeah. So that's what I've been working on, my ZX Spectrum. It's now pretty much finished, I think.
So it's done, eh? Yeah.
It's done, yeah. I think it looks nice. Everything works. Could be time for a production run. And
it looks real nice. Like I said the other day, I want to try that printing with the collars.
Well, I mean, it's amazing how cost effective it is for doing stuff like this. So you can get fantastic results. I don't know how durable and long lasting it is. I mean, it goes through kind of reflow ovens and stuff like that, so it must be fairly stable and solid. But yeah, it's great. It's amazing. It looks.
What's that socket on the other side of the display?
The one here.
No, closer to the display.
This one.
Closer to the display.
Oh, I was experimenting with 2 different displays. So this is a 18-pin display. This one's for a 10-pin display. But I did find that the 10-pin displays I was getting don't have the stiffener on the ribbon cable. So they don't actually fit into the socket. They just fall out. So I will go for the 18-pin ones, I think, or just solder it directly to the PCB. Yeah. So yeah, it works really well.
What's the texturing?
That's just the ground plane. So it's a hatched ground plane. So I might switch to a solid one because the texturing actually doesn't really show that badly. But yeah, I don't know. I've got some. I think
it gives it a vibe. But you went with a 2-layer board, but how thick are those traces? They seem really thin.
They are very thin. Let me see what KiCad says they are. They're probably ridiculously thin.
Did you have to pay extra thin? Is my question.
I didn't pay extra. No. So what's that then? So that is 0.2 millimeters. So I think it's not that thin, is it? Maybe it is 0.2 millimeters. What's that?
Oh no, 0.2. That's above the minimum for standard PCB, right? It's 0.16.
Yeah. Yeah. I do need to. Oh, look at that. That's terrible. Oh dear, who did that? Oh, look at this one. Oh, that's rubbish. Gosh. sack the layout person. Terrible layout.
It works.
It does work. Yeah, I mean, this routing was. I guess in a way it's quite a simple PCB really, because the SD card just routes straight into the ESP32, so that's quite simple. And then the display, you just route straight out to the display, because the S3 is so flexible with its pins. It's sort of really can just pretty much do anything. So you can make the routing actually quite straightforward if you kind of just keep moving things around so that you're not having to sort of cross wires and do stuff. So
yeah, Chris, you're frozen. I don't know if you could. Yeah, visually we can hear you though.
Okay, let me restart my camera. This is, as I say, technical issues. Let's see. Stop cam. No, I'm frozen completely. Let me fix that. But I think I'm done with my demo anyway. So that's kind of lots of layout,
really nice,
and fun stuff. Yeah, I mean it does look fantastic. It is really nice. Don't know, where's that 3D view gone? It's come on a different screen. So yeah, that's interesting. Strange effect. Anyway, yeah, I'll stop sharing because I am suffering from terrible technical problems. So let me get my camera fixed, and yeah, over to you, Pat, or deshipu, whoever wants to go next.
Let's.
Does that mean me?
I think that means you, Pat.
All right. Well, the short version is that I do lots of board dev and stuff like that. And if you use FPGAs or interact with them or anything like that, you've dealt with PMODs. PMODs are this standard-ish form factor for these little modules that you can connect into things. I have a whole bunch. I've got screens and flash and LED segment drivers and da-da-da. So often you want to interact with them. Also, sometimes you're actually on the other side and you're trying to develop something that will act as a peripheral module for whatever it is. So I wanted a form factor that was usable in the PMOD way, but that was also flexible, because it's nice to have a digital, a rotary encoder or whatever like that. But, I want something more flexible than that. So what I ended up doing is basically this. So I stuck an FPGA and then gave it a bunch of PMOD interfaces. So these two here are peripherals. Well, hold on. I'll switch to the bottom camera here. So, yeah, you can see this. Okay, so this is basically the anything PMOD. And the anything PMOD is basically any PMOD that you want it to be, because it's got two peripheral PMOD interfaces and one host interface. So that's why this is female and these two are male. And so I interact with lots of things, and this allows me to develop my own PMODs or interact with things that have PMOD headers. Now, not coincidentally, I like this standard. So when I designed the Tiny Tape Out demo boards, stuck some PMOD headers on it. And right now I've been playing with a project by Ronaldus that has an AY8913 or something like that, a 3-voice sound generator basically from the 80s or 90s on the chip. So this is the ASIC with the projects. This project is preloaded, and I've got a little PMOD here, a DAC output that's going to a little speaker over there. So like this, yeah. So I'm just going to show one example. So in order to play with it, I've been using the Raspberry Pi, the RP2040, to talk to this project. But right now I was trying to dev this thing. So instead, I basically created a program where, well, it's not a program. There's no CPU on this thing, but it's all hardware. So that's pretty cool. So what I have is something that will, on one hand, talk to this flash PMOD here. So it's acting as a host and dealing with this guy. And then it's acting as a peripheral on this device and talking to the inputs and to the BIDIR. So let's see if this is going to work. I'm plugging it into USB. Now it's a bunch of hardware running in parallel, right? So the whole advantage of the FPGA thing. And I need to change this form factor just a tad. So one of the really neat things is I actually got, thanks to TNT, Sylvain Minot's bootloader, I can basically install the bitstream through USB. And the other thing is it actually has a CPU-less USB ACM implementation. So if I share the desktop here, I'll show you something pretty sweet. Where is it? Desktop. Yeah. So right now I'm actually connected to this FPGA, and I can say play. Oh no, now it's dying. Shit. Of course it's a live demo. Everything's gonna.
I think my technical issues are contagious.
Okay. Yeah. Okay. So let's see. This thing is now loading the project. This thing should actually be ready to go if I can plug it in here. And what do I got? I can pause it midstream. It actually, the project here is registered, so I don't know if you can hear this wonderful music, but the project is basically has these registers, and now it's set up with this sound. And if I continue the music, let's see, here's the desktop. The program's still a bit buggy, but I think it's kind of neat. So basically that's it. In short, I'm going to be taking these boards, and so I've developed, a bunch of firmware stuff using Amaranth for it, and I've got SPI, UART, the USB. I've got a whole bunch of stuff running. So I'm going to release all this stuff at some point in the very near future, this summer, anyways, and put the demo, the PCB and stuff online, and then the libraries and everything if you like to do your hardware in Python. And that is pretty much my story. I don't know if any questions came up while I was looking at that stuff. Yeah, 8-bit computer sounds. That's right. I've been in 8-bit land. We're all in 8-bit land these days. Chris's project, this stuff, it's pretty neat.
So how big is the FPGA on it?
Could you repeat that?
How big is that FPGA on that board?
Oh, it's a Lattice up 5K. So it's got 5,000 LUTs or something like that.
Nice.
Very nice. Is it easy to program? I mean, how hard is it to program it?
So that's one of the really neat things. Like I did for the FPGA demo board that goes with the tiny tape out stuff, it's a Lattice up 5K, and I'm using the NO2 bootloader firmware. So in essence, this thing resides on the FPGA as a bit stream. If you are holding the boot button, like while you come back from reset, it will boot into DFU mode.
Right.
And so from the computer or from a browser, you can actually send the bit stream, and then it restarts. And then because you're not holding a boot button, it loads the other slot.
Right.
It loads, there's a few slots actually. And so it's basically a DFU bootloader that takes no space when you're not using it. It's really cool.
Very cool.
There is a question about what PMOD is from Guido.
Yes, it is a Digilent thing. Basically, the PMOD standard it basically says that here's a connector. It's got 8 I/O, and there's where they are if you're the host, and there's where they are if you're the peripheral. So that I/O1 will connect to I/O1, and ground and VCC will connect from the host to the peripheral. And so that's the spec for one of these connectors. And then there's the spec for the spacing between connectors. So you can have these dual things like this LED, 7-segment thing where it has 2, and it'll fit on any FPGA that has 2 PMODs in a line. And finally, there is semi-spec, but it's actually pretty good for the placement of where the lines go if you're talking SPI, for instance. So the CS will be here in pin 1, and the SCK will be in pin 4, and stuff like that. So when I did the demo boards for Tiny Tape Out, these guys, we basically, let's see. So for these guys, I basically put 3 PMODs that, don't care. This is all inputs, all outputs, all bidirectionals, all outputs. But on the side here, these guys try to respect the spec and say, okay, well, there's going to be an input here, probably an output there. And so one of them is like a SPI thing. One of them is like an I2C or UART thing, things like that. So in essence, yes, PMOD is a spec, and it might be super copyrighted, trademark word, whatever, Digilant, whatever, but I'll just call it, the PEE mod or something, and it'll be fine.
Nice. It's really cool.
Yeah, sounds like something, very useful, especially if you want to develop, you have an idea for something and want to test it before you actually make the physical thing.
And it actually came up when I needed to interact with something, I can't remember what, and I needed a flash and one of these, which I now have, which is just a rotary encoder as a PMOD. I mean, I don't want to build it. I could just say what it is on an FPGA and plug it in, and it would work. So I was like, I need a configurable and anything PMOD, and that's what this is.
Very nice. Okay, thank you. I guess this is my turn. So I will. Few Makercasts ago, I showed you this fluffback robot. Basically, let's switch it on. Right. So it's a small 4-legged robot that fits on your desktop and runs. This one runs on ESP32 S2, but you can plug in any D1 compatible board in there, and the size of it basically is dictated by the size of the servos I used. I used the super cheap, those blue 9-gram servos, and then basically that's what I came up with. But then I found out that you can actually find pretty cheap servos that are a bit smaller. So after a while, I made a 50% version of the same robot. And since I needed a smaller microcontroller board, I used the Seed Studio Xiao in there. So you also have a wide range of microcontrollers you can use with it. There is a Xiao with an ESP32 S3 and a camera on it on top. So you can even have like a camera facing forward for some shenanigans with vision or whatever. I got the streaming to a browser, for instance, working on it, so you could have like an Explorer robot to see what's on your bed. But if you can make something 50% smaller, you can also make it 200% bigger. So I found those, those are not micro servos, those are regular servos. And I found those in my drawer, and I made kind of a bigger version of it. But can you mute yourself? Yeah, thank you.
Sorry, I thought it was...
And this one, the problem you get when you make something twice as big is that it becomes 8 times heavier, because you get the cube law. Basically, it's a 3-dimensional thing. So I had to go with the aluminum legs instead of. I started with wooden legs, but they would break. And so this you see, I just used some servos that I had in my drawer. I used a Pico clone with a display, this one, but it's basically a Pico. Some ready boot converter, because actually back converter, because 2 batteries needed to go down. But it's janky. So I thought, okay, maybe I can make something even bigger than this and a bit nicer, so I can take it to conferences. And I also wanted to be it. You also it works pretty slowly because those servos are quite slow. They are powerful but slow. So I thought, okay, I if I used faster servos, I could make it walk as fast as a human. So I could have it on a leash, or walking in front of me at a conference. So that would be pretty cool. So I got to this thing. I got some nice aluminum case for it, and I got some nice aluminum legs cut at the CNC service, and they even anodized it for me. So it's a very nice thing. Those are actually you just send them a step file, and they can cut it to any specification you like. I also saw, professional robots have this emergency stop button, so I thought I need to add this. So there is the stop button that makes it. I still need to program a little bit more fluent movement of the legs, but that's basically it. And it has also a speaker in there, and it has an infrared sensor, so I can control it with a remote.
Very cool. It's a little bit scary.
Yeah, well, spider robots tend to be. Yeah, it's a bit. But, at least it doesn't look like a dog or a human, and doesn't look like something you would like to pet. So I hope that will make people at least, not try to pick it up and pet or whatever. I actually replaced the tops because the case normally came with the metal plates for the top and bottom. Because I didn't want to drill holes in them, I replaced them with thin PCBs. That also makes the whole thing much lighter. So weight is a very important thing for walking robots, because basically they are like drones. They have to carry their own weight. It has the same 2 batteries inside and a custom PCB, also with a shell on it. So it's a bit funny that the biggest robot has the smallest microcontroller inside of it, but it's 2 pieces.
Have you thought about making these into shoes you could wear, so you could have a spider robot on each foot, and then? Well,
it wouldn't be able to carry your weight. It barely can carry it. It's 12 kilogram servos. Okay. That's kilogram times centimeter, and the leg is 11 centimeters long.
Yeah, okay. Power needed.
but it's a worthy goal. I don't know if you saw the guys who are making these Boston Dynamic type size dog things. They're not using servos. They're using these. I think they're just DC motors, but with some sort of feedback in the loop.
I don't know if you had any chance to see it live in person. I had, and they are basically vacuum cleaners on legs. So they need so much cooling that the fans are actually louder than the motors.
Interesting. Okay.
It's like a wind tunnel on legs, really.
Maybe you could maybe a swarm of walking robots that you could lie on as a
So with those
things, yeah.
And
without
with each other.
You really want something to carry you, huh?
I want something to carry me, basically. Yeah.
Yeah. So this still needs some work in terms of software, but that's always the case, right? Software is the difficult part of those things. But I'm really happy with the hardware I got. I even got there are holes at the ends of the legs, so I wrapped some rubber string around them, so it will not scratch the floor when it's walking. So yeah, thank you. That's all I got.
It's really neat. What are those servos?
I don't remember the exact. There was the symbol written in. No, digital servo. Yeah, I don't remember the exact model of them. I have everything documented on hackaday.io, so you can check there. I just looked for the fastest servos that are at least 12 kilogram of torque. They can get quite expensive at some point. So those are the cheapest Chinese ones, of course. But big strong servos that are also fast are getting expensive quickly. So I also tried to get it in like below $300 budget. That's why I prefer the small ones. The small ones are like $30 totally. So the smaller you go with robots, as long as you have the off-the-shelf parts and you don't have to make custom tiny things, the smaller you go, then the easier it gets. Also because of the inertia. If it's small, you don't care. You can drop this robot. You can drop from the desk. It will not even notice. If you drop that one from even like 20 it will immediately break completely. Okay, we can now, this is the end of the official part, and we can now chat. I didn't prepare a quiz or anything like that, but I thought maybe we could talk about, general things about projects, whatever is on your mind at the moment.
I'm okay with that. You killed me last time with the quiz. I think I got 0.
Yeah, I'm sorry. That was actually bad design on the music one, right? I should have done it that everybody can. So it's not like the first person that guesses, but everybody can guess. And then at the end, we just.
I still would have got 0.
Well, it's computer games. Not everyone play them.
Yeah, the only quizzes I seem to do well on are the ones I set myself, where I know the answers.
It was my revenge for the Star Trek quizzes. Because then I always get 0.
Well, actually, sometimes some of my quizzes, I can't actually remember what the answers are. And I think, Pat, last time you pointed out that one of the questions was wrong anyway. And that was, I think
that always happens.
The gremlin question. Was it you who spotted that I got the gremlin question wrong? Or was it someone else?
Probably not.
Probably not. No, someone else then. But yeah. I can't even get my own quizzes correct, so that's terrible.
Well, so one common, one famous question on the quiz was, there was a question in some pub somewhere. They asked, what is the main chemical ingredient of sand? And there was a chemist present who argued argued for half the evening that his answer was correct, and it's oxygen.
Because there's 2?
Yeah, but both by count and by mass, there is twice as much oxygen than silicon in sand. So the main ingredient of sand is oxygen.
So, for the chat moment, do new materials or devices come on the market which you consider to use in a project? Well, for me, the full color silkscreen is more of a sort of technique that came onto the market that suddenly became available. So that was kind of what drove me to do this Spectrum thing, was just there was a new thing available from the manufacturers that suddenly you could do full color silkscreen, and then it's kind of what project can I find that I could use full color silkscreen printing for, and a keyboard seemed like a good one. Devices, I don't know, Pat. You're more cutting edge than me, Pat. So you're always doing FPGAs and stuff. So are you?
I'm a little bit behind on things. There's a few things that I've kind of stacked up that I want to play with. There's the that Chinese CPU there, the $1 CPU thing. That there's a whole little range of them. The MV numbers and MP numbers. I can't even remember. So that's one of them. And then, yeah, okay, so that's it. And I still haven't played with those, but I want to do it because I'm going to, I want to use it on a little carrier board for another of Ronaldus's project, the Z80 thing. So that's one thing. And I'm so sick. I mean, I use the Lattice FPGAs a lot. Not because they're super the awesomest and not because Lattice is super nice. No, because it was reverse engineered and we have tools that are open to use it. Well, I'm sick of fighting against the company to use an FPGA. And apparently there's these German guys, right? I think that have this open FPGA. I can't remember the name either, but that is something that's on my stack. I was like, oh yeah, this is what I want to use. And so those are the two things that I'm really interested and keen on using that I haven't before, but they're not completely new.
Yeah.
Anything else?
How about you, deshipu? Any cutting edge stuff that you? What kind of drives you for projects? And do you see new stuff appearing, and you think I could do a project with that, or?
So my projects generally start always with I have some idea and I think, okay, this needs to exist. So and then I look for things that would fit this particular idea, but I also try to research new things and like this $1 chip thing. I have it on my desk because I wanted to try it at some point, but haven't got the time yet. So I try to kind of keep my toolbox open for new things, but projects generally are not inspired by what appears on the market, but what I think that should appear on the market.
That's quite an interesting question. Where do you get your inspiration from, or what triggers the trigger to actually do a project and inspiration? Where do you find that comes from? So, Pat, what makes you do stuff?
Well, there's a reason I always end up making tools, and that's because I'm doing something else, and then something gets in my way. And so I make software. I made the KiCad scripting library. I make these plugins and extensions to the pick and place machine. I make these little boards that are just all tools. So usually I'm only scratching my own itch. So it's like the market, let's say, is pretty damn niche. Okay, not everybody's going to need this super tool to do this one specific thing, but that's where irritation, I guess, is my muse. So, how
about you, deshipu? Where's your inspiration come from?
So I'm very much visually driven. So it's always usually I see something and I think, okay, this is cool. We need to make that happen. So most of my computer, I got into computer because of the arcade games. Most people tell, okay, I had a BBC Micro or I had a C64 or something like that. That wasn't available in Poland at the time. So the first computers we actually saw, like for general public, were arcade machines at the train stations. And I would spend like hours. Of course, I didn't have the money to play. Because you had to put the coins in, right? So I would just look over the shoulder of people who were playing and for hours at a time in there. And then when I finally got, my parents got a computer for work, I found that I could, implement some of those games, some like small recreations of those games on that computer, and that got me. But it's all visual, and even now I have that game console thing. It also, it uses big 4x4 pixels on this screen, so that you see the pixels, because I still am in 90s in that aesthetic of the pixel art and so on. So with the robots also, I could make that robot a robot dog. It's basically the same number of servos. You just change how they are attached to the body, and you get a dog. But the idea of a spider robot is much more important to me. I really wanted to make it look insectoid and not, and not a dog, basically. So that's it for me. You?
It's funny because I got a similar start with computers, in the sense that my friends had these supercomputers with games and stuff, and I was like, I want a computer with games. And my father got me a computer. It had no games. You turned it on and it was a blinking cursor, a basic prompt. And so 10 print hello, 20 go to 10. No games. What the hell? But back in the day, it came with a manual. Well, shit, I'll write my own game, right? So I'm learning basic. I'm writing these little programs. I end up writing a whole game. Played it 3 times. Turns out I liked programming the games much more than the games themselves. And that sent me on a whole path.
Yeah. So what I discovered is that you can make games that have randomly generated content in them, and then you can play them. Because, it's boring if you already know what's in there, right?
Yeah, I think anything that's procedurally generated, or anything that you just give it a random seed and that creates a game, is really fascinating. I find that really cool, how something complicated can come from some simple algorithm, and you just kind of...
Chris, you didn't tell us what inspires you.
Yeah, what inspires me? Good question. Generally, I think it's a bit similar to you, deshipu. It's stuff I see and I think, well, someone should build that, or I could build that, or that seems like it's possible. I'll try and do it. When I first started, it was just me exploring things like the ESP32 and working out how they worked and how to use them. And I'd think I could make a video on that. So it wasn't so much project driven. It was just I'd learned something and I thought I'd share it. And then it got into I could actually build something. So I'd like to build something like this. And then it's sort of, is that possible? And then when it is possible, you kind of go, I've got to build it now because it seems like it's possible, and I want to sort of see it working. And a lot of the times I'm sort of, once I've proven something can be done, then I find myself losing interest. So actually taking something through to production is a big challenge, because it's kind of, once I know it works, it's time for the next project, because I've proven that I could do it. Even if it kind of only half works, I'm sort of close enough that it's sort of, well, it can be done and somebody else could take this further. But the interesting bit is done, because that was the fun, challenging bit, and now it's kind of just hard work. So I kind of enjoy the proving it can be done.
The fun stuff, yeah. The rest is an exercise for the reader.
Exactly.
Why you need an assistant?
I need some clones and some assistants. Yeah. Or I just need people who want to actually do the hard bit, so I can do the fun bit.
No, ChatGPT only will do the fun bits for you, and that's how AI works,
That is true, yeah. But yeah, it is kind of like, yeah, I do have that problem of once I've shown it can be done, it's kind of, next project. Yeah, so it's a challenge. Productionizing stuff is just really hard work. That's the problem.
I feel like it's worth for everyone to try it once. And
and then realize what a nightmare it is and stop.
Because it's valuable things you learn, but once you've done it once, It's kind of
Yeah, I haven't done direct to consumer ever. I'll try if I ever have something that has the chance of selling more than 3.
Yeah, well, I'm gonna try with my Spectrum. I'm gonna try and sell that in a proper. Try and sell enough of them that it makes sense and is a real sort of production run of things. So
That's a good one.
Yeah, try and sell kind of a couple of hundred. I think that's an ambition of mine. If I can sell sort of 200 or something, that feels like a big enough production run. Even though that's kind of like a tiny production run, for me that would be like a kind of I've done it now. I'm not doing that again. So,
yeah, that's on the level of the demo boards. Actually, the people who are doing tiny tape out, there's a few hundred per run. So these runs, I'm hardly counting them, but they still count actually.
Still count. I think it's enough that you're kind of doing some QA and you're having to kind of think about sort of how they're going to test.
That's the problem. The headache is the same. No matter if you're doing 50 or 3,000, you're basically
exactly. Yeah,
amount of work.
And Guido's right. It's the support and stuff like that. It's the expectation of support and how much help people need, because
and also getting the project to the stage where you can actually, confidently say, okay, produce 300 of those, and I will not have to do 300 budgets on it.
Yeah, that's always the thing that worries me, because every time I make a PCB, there's some kind of mistake, and it's this endless thing of kind of there's a mistake somewhere, and then you think, do I want to push a button that is going to cost quite a lot of money, make someone do a lot of work, and I'm going to get like 200 broken boards that don't work, or 200, even worse, 200 boards that I need to solder bodge wires onto to make them work. It's just that's not really fun.
I once made 1,300 conference pages for a conference.
Yeah,
and they arrived on the day before the conference. Even if there was a badge needed, it wouldn't be possible. So that was a lucky thing.
Yeah, I mean, I guess with the one I've got now, it works. I know it definitely works. I've tested it, so I could just go, well, I could make lots of these, knowing that they should work because I got one working right in front of me. So in theory, what could possibly go wrong?
Well, one thing that goes wrong is that things break in transport.
Yeah, and manufacturing defects. I mean, it could be that I've got lucky and the ones that came worked, and somewhere I've got some tolerances that aren't great, and manufacturing lots of them would mean lots of them fail. So I just get the fear.
The first game console I made, I sold some on Tindy, and people would complain that the speaker stops working after a while.
Right.
And that was a tiny metal speaker on them. And when I asked, that was made at Makercast. When I asked them about this, they said, "Oh, we are actually washing the PCBs after manufacturing, and we didn't glue the little hole in the speaker."
Yeah.
You have to cover that hole, otherwise the liquid gets into the speaker and corrodes it over time.
Nice.
So things like that, there is no way you can predict.
No. Yeah, definitely. Yeah, cool. So we'll start manufacturing then. Set up shop.
You're going to go through a CM, or you're just going to have, PCBWay or whoever make your bunch?
I'll probably just get PCBWay to do it, because it is just a PCB with SMD components. So there is very little. Well, there's not really any manufacturing to do apart from stick the display into the socket and put an SD card in. Is the sum total of assembly. So
all those parts are just standard LCSC type stuff.
Yeah. So it's all out of the box. It all comes from China and gets made in China. So yeah, it's yeah. So I can get. It's not going to be that expensive to manufacture. I think once I go into kind of actually producing a lot of them, the cost of the PCBs goes down so dramatically, and
Also,
to do
the
it-
PNP,
so
the pick and place gets much cheaper as well.
the base gets much cheaper, and the color silkscreen printing doesn't seem to add very much cost at all. So it doesn't. It's not like it's an exotic process that costs lots of money. So it's just part of their standard PCB offering. So yeah, I think it should be. It's definitely doable. So I think I'll do it.
And the fact you don't have to ship them a whole bunch of CPUs. I had at some point had to ship these NRF 9160s, these LTE chips and everything.
Yeah.
They're really expensive. They're GPS and LTE chips, and we had these and a bunch of NRF 5340s for the Bluetooth, and had to get those over to them.
Wow.
And it cost, and it was slow, and it was scary as fuck, because it's like, okay, they're going, and then there's delays in customs, and then these fees and this and that, and you're like, oh, I hope nobody in China feels like a whole bunch of chips. That was more expensive than the rest of the production run. Anyways, so we had sourced them here and then sent them over.
Yeah. Would you, in those situations, would you ever consider just having the PCBs made in China and then doing the SMD assembly locally in a local shop, or is that still?
That's expensive. I mean, I prototype in house, and I'll do 10 or 30 in here, but not more than that, you know.
Yeah.
So it gets really annoying, and that's not my specialty, let's say.
Hmm.
And so at some point you want to have it done over there, and that's why having a middleman you can kind of trust and say, look, I'm going to send you the chips and you can do the finalization and the testing. You be my hands over there.
Yeah.
And it's pretty practical.
Yeah, so I had those done.
Wow, that's a lot of boards.
Also like game console type things for a workshop. And the problem is, of course, you have to solder the display and battery yourself, because they can't pick and place that. That was the DLC, you know, the chip, the economy pick and place thing. But also they ran out of this is a SAND 21 chip, and they just ran out of them. And I had them in my drawer. So I said, okay, just make everything else, and I will solder the chips myself. And how hard can it be if you solder the QFN32 chips by hand? Turns out it's 2 days of work and you're done. It's not super hard, but next time I would pay someone to do it instead. So it's not. Yeah, for 50 boards, it's still, you know, whatever happens, you can still kind of fix it yourself. Problem also is that those ones were fine because I needed them for a workshop, so I needed them shipped to myself anyways. But generally speaking, shipping from China is much cheaper than shipping from Switzerland.
Which is another reason to use someone over there. I mean, I don't know if PCBWay or the other guys would do that, but a middleman will.
I know Electro does this and Makerfabs does it, so they can, you know, you give them the list of addresses, and they will ship them to.
Yeah, interesting. Yeah,
and you know, they will use. They also have like a deal with the shipping company, so they even get better prices.
All of China has a deal with the shipping company. It costs me more to send a letter to my neighbor here than to get an object from China. It doesn't make any sense at all. But
yeah, exactly. The government is basically subsidizing that, and it's working for them. So
yeah. Cool. All right. Well, it's 10
Yeah.
o'clock.
Thank you, everyone, for
Hey, thanks for hosting. Brilliant.
super interesting project, and thank you, everyone, for listening, for coming
To the audience.
at such short notice. We promise we will try to be more predictable with Makercasts, but if there is nobody coming with projects, there is really nothing.
I saw someone in the chat was saying they wanted to come.
I think Envy was.
Yeah, Envy, you are more than welcome.
Very good.
We had Envy before in here. I
We
think.
did, yeah. Yeah, he's been on.
Also, if anybody has, wants to come to Makercast, then just contact anybody of us, and we will get you an invite to the secret Discord channel. And you can.
Just don't stop us.
Okay, thank you, everyone. Good night.
Thanks for hosting. It was nice seeing you. Take care, guys.
Bye.